Good afternoon or good morning to those on the West Coast. I want to thank you for joining today. And my name is Sean Evans. I'm going to be hosting today's webinar. We've got a great presentation lined up for you. But before we start, let's take care of a couple of house cleaning items. One, we're going to encourage you to use your computer speakers. If not, the dial-in information you can see below there on the screen along with the access code. And when you join, you'll be shown a pin to join the webinar. And so without any further delay, let's go ahead and get started. Okay, so today's presenter is Lee Gerard, and he's the Lifecycle Management Product Manager for our ATG platform here at Veeder-Root. And a little bit about Lee is Lee has over 25 years of industry experience, including ATG, vapor recovery, fuel flow, submersible pumps, and other hardware, including hanging hardware. And he has a technical field and sales experience background, and just brings a lot of great experience to this topic. And so without any further delay, I'd like to go ahead and turn it over to Lee.
Okay, so today we'd like to cover some basic EPA regulatory requirements. So for today's agenda, what we want to do is look at what the requirements are for a petroleum underground storage tank system, what type of release detection methods you can use, and if you've been doing this for years, some of this is going to be very familiar to you and some may not. We're also going to talk a little bit about the best compliance methods for your particular site dynamics. And the last thing we want to talk about is just demonstrating some of the compliance methods and reporting that you can use when you're using an automatic tank gauge like a Veeder-Root system. And then on the bottom is a hot link that you should be familiar with, because this gives you great resources for the EPA requirements. So the first thing I want to talk about is the EPA requirements. Some of you may or may not know that there's new regulations that have come out, and that's going to impact everybody who's a tank owner, one way or another. So first we want to talk about tank leak detection for petroleum, and in the EPA reg it's section 28.40. So basically what it is, they want to ensure that there's regulations out there that regulate tanks and make sure these tanks have some type of release detection so it can discover a leak quickly so it doesn't contaminate the environment and do any more damage to the underground. So there's four things that they basically want us to go after, and so you must provide some type of release detection that allows you to meet these four basic requirements, and these are the ones below. So the first one is you have to be able to detect a leak from any portion of the tank routinely that contains petroleum. And in addition, your leak detection is installed and calibrated in accordance with the manufacturer's instructions. And then on top of that, your leak detection has to be operating and maintained and tested in accordance with the manufacturer's instructions. And then the fourth aspect of it is your leak detection uses one of the 7 methods described in the federal regulations, which is in 28.43. So let's talk about the release detection methods for tanks. So these are the 7 that are listed. Monitoring methods, basically monitored every 30 days here. So you have 5 options here. So you have automatic tank gauging, which some of you are familiar with. You can also monitor the vapor in the soil. You can also monitor liquid in the underground for groundwater. You have interstitial monitoring as a method, and then you have statistical inventory reconciliation as a method. Or you can utilize weekly manual tank gauging, or you can do annual tank tightness testing with daily inventory control. So, and as a note over in the upper right-hand corner, for tanks installed prior to April 11th of 2016, 7 methods are available, so you can use this, as long as they were installed prior to 2016. After that date, any double wall tank is going to be required interstitial monitoring. So the thing we ask you to do for your region is always contact your state and local regulators, because they may exceed some of these federal requirements, and it's in your best interest to understand what they're requiring on top of the federal aspect. So again, for the tanks installed after 2016 in April, interstitial monitoring will be the only permissible method. So let's talk about the first method on compliance, using an automatic tank gauge. Basically, an ATG system can detect leaks throughout, through a highly accurate inventory measurement by tracking delivery information and dispensing activities. What the regulatory requirement is that you have to be able to detect a 0.2 gallon per hour leak with a 95% probability of detection with a false alarm rate of 5%. Most of those ATGs that are out there have that capability. The ATG must also perform inventory control. Most of those ATGs today do have that capability. And then the next bullet, the ATG must be operated in one of the following modes. So if you're utilizing this method, you have static testing, which we call SLD, or static leak detection for Veeder-Root, and this needs to be conducted every 30 days. This is primarily a great way of doing tank testing if you have a facility that is closed at night, and you can program the TLS to run a test every night or once a week or once a month. The next method is a continuous in-tank leak detection, or Veeder-Root's mode is called CSLD. And this basically operates in the tank during quiet periods throughout the day. If it has enough quiet periods, it provides that 0.2 leak test result for you. So an example of the equipment, an ATG that meets a regulatory requirement would be like a TLS 450 Plus, like demonstrated here in the slide. Probes with leak detection capability, such as the probe, and then optional software to be able to run those tests. The second method that you can use is vapor monitoring. Now, vapor monitoring allows you to measure fumes from a leaked product in the soil around the tank area. Unfortunately, this is a reactive type of device, because the leak has already occurred, and now you're contaminating the environment and you're picking it up, which is great that you're picking it up. However, it's not proactive like doing in-tank testing or doing interstitial monitoring. So, what are the regulatory requirements? You have to have porous material in the excavation zone. The area has to be free of interference such as groundwater and rainfall that would prevent detection. So this is very good for low water tables. And then you have to have a sufficient number of monitoring wells. Monitoring wells are determined by a geological survey that would be done on your site if the site doesn't have monitoring wells currently installed. So again, example of equipment that could be used. You could use vapor sensors for monitoring wells, which can be hooked up to almost any ATG that's out there. And then you could also use continuous monitoring sensors like the vapor sensor we're showing here. The third method of compliance is groundwater monitoring. Groundwater monitoring basically involves a permanent well that's placed around the UST system, and they're typically located based on the groundwater path. So there might be more on one side of your tank farm than the other, because that's the way the geological survey was conducted with regards to groundwater movement. So these groundwater wells allow you to take a sample from those wells periodically and have them evaluated if there's fuel in those wells. Again, unfortunately, this is a reactive type of leak detection, because the leak has already occurred and it could have been leaking for several days or weeks or months before it's even detected. So the regulation basically says you have to, you can do groundwater monitoring up to 20 feet of ground surface. You have to have the ability to detect 1/8 of an inch of product on top of the groundwater. and you have to have sufficient number of monitoring wells, again, to be able to detect it on your location. Again, an example of equipment, there are groundwater sensors that can be used with an ATG that continuously monitor these wells. The next method is method 4, which is interstitial monitoring, which we talked about a little bit earlier, which after April of 11th of 2016, new locations, this is the method of leak detection. So basically, interstitial monitoring, basically a secondary containment that has a barrier between the tank or a piping system, depending on what you're doing. And that barrier holds that leak between the tank and that barrier, so the leak is detected and it's contained. That's the bottom line, to contain it also. The barriers can include double wall USTs that have an outer wall that surrounds the primary tank, which if you've been in the business for a while, you've seen them. There's double wall fiberglass tanks. There are Stipe 3 tanks that are steel tanks that are lined with fiberglass on the outside, and they can have a brine-filled wet monitoring system, or they can have a dry annulus system also. And again, you know, internally fitted liners and bladders are acceptable as a method of interstitial monitoring. Continuing with method 4 with interstitial monitoring, sensors for interstitial monitoring can be multiple things. You can use a dipstick with water or fuel paste to actually monitor the interstitial space. You could use a non-discriminating sensor to detect dry space. You could also use a discriminating sensor to detect the presence of hydrocarbons or fuel in those spaces. And then we have different types of sensors out there for the brine fill or the hydrostatic type of double wall tanks that have brine in them that can detect the level changes of the interstitial when it comes to a hydrostatic type of application. And then the fourth one would be secondary containment vacuum sensing. This actually allows you to put a vacuum on the interstitial space and monitor that vacuum over time and continually monitor it and generate alarms if it's using an ATG to let you know that you potentially have a leak in the site. Now, what are the requirements? Interstitial monitoring must be checked at least once every 30 days. So if you have an ATG with an interstitial sensor, technically they want to see some type of sensor status report once a month. Now, the fifth method, which some of you may be using today, is Statistical Inventory Reconciliation, or SIR. Basically, SIR analyzes inventory, delivery, and dispense data, and it collects it over a 30 to 60-day period, and it determines if the tank is leaking or not. What the requirement is with that is basically a 0.2 gallon per hour leak detection method that meets the monthly requirement for the life of the tank. It also, requirement is the 0.1 gallon per hour leak detection, which is going to meet the federal requirement as an equivalent to a tank tightness test. And if the SIR system has the ability, it can also provide tightness test results for your product piping systems. There are services out there, if you're not aware of it, that can be utilized for SIR. Typical SIR applications are going to be locations that are large throughput sites that have no quiet time, they're not shut down, and they exceed the third-party thresholds for static leak detection or continuous leak detection. The SIR is a possible method for that type of leak detection. The sixth method is manual tank gauging. Now, this is labor intensive also, so this is a manual measurement at the beginning and the end of a 36 to 58 hour quiet period. That's what stays in the requirement in the regs. And basically the tank has to be idle for that period. You can't add liquid or take it out during that period. Now, there's limitations. It can only be used on tanks that are 2,000 gallons or smaller. Tanks that are 1,000 gallons or less, use this method alone, you can do that. If tanks are between 1,001 to 2,000 gallons, they have to must combine this with periodic tank tightness testing. And only for 10 years may they do this. after installing the new UST or upgrading it with the UST corrosion protection. So this method requires taking the tank out of service for at least 36 hours each week to take a measurement of the tank's contents. Not very practical in today's business on the retail side. Maybe on some type of industrial application you could see this. The last method is tank tightness testing plus inventory control. This is a combination of two methods. Again, it's tank tightness testing and inventory control. Tank tightness testing requires an annual test conducted by a certified vendor who has been certified as a tank tightness tester. And when they do that, they're going to have to suspend operations at your site to perform this test. In addition, you have to do daily inventory level measurements to 1/8 of an inch accuracy. You also have to provide monthly water level measurements to 1/8 of an inch accuracy, and then provide monthly reconciliation of deliveries and dispensing, and monthly calculations to prove the system is not leaking. So you have to do these in combination with a tank tightness test to use method 7. Now, what's the regulatory requirement on it? Monthly calculation must detect a leak at the federal standard of 1% of monthly throughput plus or minus 130 gallons. There are states out there and counties that have tighter restrictions to that. For example, in Massachusetts, it's 0.5% plus or minus 50 gallons. And then on top of that, you also have to provide an annual tightness test that can detect a leak of 0.1 gallons per hour. Again, this method can be used only for 10 years after installing a new UST or upgrading it in the UST with a corrosion protection system. So let's talk about what's the right compliance method for your site. So if you have single wall tank application, you got to choose one of these. So if you have an automatic tank gauge today, you can utilize our continuous statistical leak detection from the Veeder-Root system, which is great for those sites that have medium to high throughput sites and no quiet periods. SLD, which is static leak detection, is the best solution for sites with quiet periods. So if you are shut down at night and your location closes at 11 o'clock at night and it opens at 6 o'clock in the morning, you can run this test every night, and it's going to at least give you multiple test results per month to be able to provide for your regulatory requirements. The next method is vapor monitoring. This is for the low water tables. It's again not recommended due to the delay in the detection and potential of wet sensors. And then groundwater monitoring, same thing. We don't really recommend it unless it's a requirement in your region. What we see a lot happen is people will use one of the SLD or the CSLD as their primary, and they'll use vapor or ground monitoring as a secondary method of leak detection, just as a safeguard. Again, with single wall applications, you can use the SIR. You could also use the manual tank gauging, which we talked about. Again, this one's not recommended because 36 hours of downtime is a lot for a facility. And then tank tightness testing plus inventory control. Now for double wall applications, the best solution is interstitial monitoring. Prevents any contamination outside the barrier. As long as the barrier is sound, then we know that this should contain it. The other methods are, again, SIR, manual tank gauging, and then tank tightness test plus inventory control. One thing that working through the years, even with double wall protection using interstitial monitoring, it's best to always keep very good inventory control records and do reconciliation as much as possible as a daily routine in your business, because you'll see that it'll help manage your business from an inventory and from a cash flow perspective, while also having interstitial monitoring as a primary method for leak detection. And then that way, when an inspector comes to your location looking for your records, you have inventory control records, reconciliation records, and your interstitial monitoring records. So I got a few slides here to demonstrate what an ATG does for you from a compliance perspective. Over on the left for method 1, an ATG with static leak detection. You have a report over here that you can print out. It gets printed out automatically after a test. You can record it, put it in your notebook. If you're utilizing some of our other features where you can remotely access your gauges, like with TLS 450 pluses, you can access them through this remote display, the picture over here on the right, and basically retrieve that data, print it out, record it, and then and file it away for your inspection every 30 days. Again, for method 1, if it's CSLD, we're actually showing you the fullest test here, and we're recording them every month, so you have a rolling record of all of your reports. With this particular tank gauge, it stores up to 3 years worth of data. Now, for methods 2, 3, and 4, which are vapor, groundwater, and interstitial monitoring, basically what you're providing is sensor reports and sensor statuses to the regulators. So on the left is a typical printout from a tank gauge that gives you the sensor status history. And then the report on the side is the same report, but just in a different format. What they're looking for is they're looking for sensor status reports from your tank gauge, at least one report a month. If you have the capability of storing this data with some of the more modern tank gauges, we highly recommend that you do that just as a safeguard. Now, with methods 5 and 6, typically it uses off-site monitoring software such as our Insight 360 that we have at Veeder-Root, and then other third-party companies do that. And then method 6, it doesn't utilize an ATG. It's strictly up to you to maintain those records, document them, get the tank testing, all the things that are involved. And then method 7 is your tank tightness and inventory control. The tank tightness side of it, you're going to get a report from a tank tightness tester and utilize that in your record keeping. With certain tank gauges like the TLS 450 plus, we have the capability of recording your inventory data through inventory history once an hour, once a day, once a week, whatever you want, set up from interval. This way, if you utilize this type of tool, you can collect your inventory daily. You'll have all your inventory records in your hands if you have that capability with that type of tank gauge. So, concluding, it's really important to understand what method you're going to utilize at your site, and then if you have questions about those methods and what else you need to do, we're a resource. You can contact us at tech support. You can also go to Veeder.com, the support page. We have lots of information there. And at this point, Sean, do you want to open it up to questions?
Sure. Thanks, Lee. Yeah, looking over, looks like we did get a couple here through the chat window. Let me tee up one here. We've got a question. Will the EPA be changing the types of barriers allowed for secondary containment?
As far as I understand, no, not at this point. There was no discussion on that. They were considering removing the bladder, but I think that's still under discussion. I haven't seen anything myself, but we can follow up with that to make sure we provide the right information there.
Okay, great. Thanks, Lee. One more point before we take more questions is this is kind of the first in a series of webinars that we're going to be doing around the EPA regulations, and so be sure to look out for more information on Veeder.com and through your email and other methods where we'll be releasing more information about upcoming webinars. I know that we are pegging one for January as well. So let's see. Now we've got one more question here. So the question here is, what is the most common sensor used for interstitial monitoring?
Okay, so based on the tank, the profile of the tanks out there, the majority of the tanks we see today are dry interstitial double wall tanks. They typically use what we call a simple sensor on the Veeder-Root side, and it's a float style switch that detects liquid. We do have sensors that can go in that same space that can detect water or fuel if that's important to the end user.
Okay, great. Thanks, Lee. Let me see if we've got any more questions. We do have about 1 minute left. Okay, yeah, looks like we do have one more question. The question here is, what would be required of the annual release detection equipment operability testing, apparently beginning in 2018, if I use an ATG for interstitial monitoring?
Okay, so the requirement is going to be that on an annual basis you will have to have a certified individual who's been certified on we'll say Veeder-Root equipment to come out and perform a annual certification on the tank gauge, and then more importantly they will have to verify that the interstitial sensors are operable, that they go into alarm when tripped. And you'll have to do that for any sensor that's installed at the site.
Okay. Great. Thanks, Lee. And we did get one other question come through the chat window here, and I think then we'll close it out after that. But question here is, how full do your tanks need to be for automatic testing?
Okay. So there's because we were talking about two different types of testing, the continuous statistical leak detection method, which runs in the background all the time, typically the certification on it is 10 inches of product. Now, most people are not running their tanks that low. If you're using the static leak detection method, which means you're going to shut the tank down for a minimum of 2 hours for the point 2 test, we recommend that you have at least 50% in the tank because that's where the third-party testing was. The minimum test level, based on our technology, is for an 8-foot tank is approximately 30 inches of product. So technically, we like to see it at 50% because that's the hardest spot in the tank to find a leak. But if you're down at 32 inches and you need to run a tank test, you can do it because the system has the ability to run that test at that level.
Okay. Great. Thanks for that, Lee. And seeing as how it looks like we're about a minute over, I'm not seeing any additional questions. I think we'll go ahead and close it out. Again, I want to thank everyone for joining us today and spending a few minutes with us. And thanks, Lee, for all of the great information today. And again, please be on the lookout for more information about future webinars. And I hope that you have a great day.
Yeah, thanks, Sean. Thank you, everybody. Have a good day.